Elon Musk is widely known for his ambition to conquer space, specifically with a focus on Mars. However, what many people may not be aware of is that the billionaire entrepreneur has a strong interest in Earth as well. In one of his recent research ventures, Musk discovered a massive object on the ocean floor that spans several miles. This raises the question: what exactly is this object, and could it have been created by extraterrestrial beings? In this regard, we bring to you Musk's latest report on this discovery. Reports from a group of alien hunters suggest that extraterrestrial life may have beaten humans in exploring the ocean. Deep beneath the North Pacific Ocean, just off the coast of California, lies a circular object that a Martian researcher believes is over 2.5 miles in diameter. Some theorists have proposed that this anomaly is under artificial control and is parked outside what could be an alien base. In a recent video shared by Secure Team 10, which is known for reporting strange and unexplained sightings, there appear to be some strange lines that resemble those created by a large vehicle moving on the ocean floor. Tyler, the YouTuber who shared the discovery, claimed that some of these tracks are not just sonar lines, but rather appear to be dug into the soil complete with shadows, similar to massive trenches. The video shows a saucer-shaped object that sits over 3,000 feet below the ocean surface. You can locate this object on Google Maps by entering the coordinates 4.250044 to 8.712918. Paths appear to surround the object, which seems to have been dug into the sand, and in the middle of the long path leading to this area are some very anomalous items. During their recent exploration, a large circular object caught the attention of the team, with an obvious path that had been carved out of the ocean soil, leading directly up to the nearly perfect circular object. According to Google Maps, the object spans 2.81 miles, and while some may assume it is a rock, Tyler believes that the zigzagging path indicates otherwise. The question remains: what is this large object moving beneath the ocean, and is it under artificial intelligent control? Measuring the path raises further concerns, as the object appears to have traveled 46 miles from its starting point. Other circular and donut-shaped objects can be found along the trail, leading to a larger structure that resembles a driveway leading up to a mansion. The perfect circle parked outside what appears to be an alien base seems to contain something, although Tyler does not speculate on what it could be. It's frightening to think of a 2.5-mile-long object moving in this direction when 90% of our oceans remain uncharted. Despite claims from some that Tyler's discoveries are too bizarre to be true, he is not the first alien hunter to make such claims. For instance, Marcelo Igazastor, an Argentine researcher, was the first to discover a mysterious underwater structure last month. He claims to have spotted a beam of light shining from the darkness of the Pacific Ocean, just west of Mexico, leading him to this monumental discovery. Scotty Waring, a well-known alien hunter, picked up on Igazastor's discovery and shared it with his followers. It is a perfect pyramid, measuring at least 8.5 miles across on one side of its base, with the possibility of spanning up to 11 miles. The massive structure may be difficult to see as it appears as a blur on the screen, but if you imagine a pyramid and squint while looking at the area, it may become visible. Waring suggests that this perfect pyramid is located near the ancient Mayan and Aztec pyramids in Mexico, although he believes that only aliens could build such a massive structure, referring to the one underwater. There are many unexplainable discoveries in the ocean. For instance, there are some strange marks on the seafloor at the bottom of the Pacific Ocean, hundreds of miles from land, that no animal could have made. Some resemble narrow troughs carved into the pale silt, while others could be claw marks carved into the deep ecosystems by an undersea monster. Humanity has left many imprints on the Earth's surface, but these long-lived features on the seafloor go largely unnoticed. They are occasionally illuminated by remote submersible spotlights, but then they return to darkness. These marks have been there for a long time and, like footsteps and tracks left by the astronauts on the moon, are still visible today with nothing to wash them away. When the track was photographed a few years ago, it was 37 years old, while the marks below date back to 1989. The marks, which date from the 1970s and 1980s, are the first tentative scrapings of deep-sea mining trials left behind by ships equipped with dredges and plows that have since departed. Scientists have recently returned with cameras and probes to investigate what has happened to the local ecosystems. What they have discovered are scars that have never fully healed, and many more tracks like these will be carved all over the ocean abyss, one of the last untouched wildernesses. What will future generations think of them, and what will they say about humanity's resource demand in the early 21st century? To understand why these marks exist and why they matter, we must immerse ourselves in a prehistoric sea. A shark shed a tooth one day, which drifted hundreds of meters to the ocean floor. The tooth gradually became mineralized as metals precipitated out of the sea and water within the sediment. So began one of the Earth's slowest geological processes, the formation of a polymetallic nodule. Although not all nodules start with the tooth, some contain a fragment of shell, a bone shard, or nothing at all. The slow rate of accretion, however, is consistent. It takes millions of years for them to grow a few centimeters. The ocean's abyssal plain is home to an abundance of nodules that have gradually covered large areas over time. The nodules were first discovered during the voyage of the HMS Challenger in 1873, but sailors who brought them to the surface would have found them to be worthless and would have treated them like rocky potatoes with crumbling edges. While the nodules may have felt smooth on top, they were rough on the bottom, where they had grown into the surrounding sedimentary grains. If held to the nose, no scent would have been detected. Despite their initial lack of value, the chemist on the expedition realized that the nodules were made of manganese peroxide, a primary substance used in the manufacture of bleaching powder. However, because of their remote location, they could not be used as a reliable source of supply. Little did that chemist know how important the nodules would turn out to be to deep-sea organisms and, later, to humans. Years later, scientists discovered that these nodules act as islands for certain types of life. The abyssal plain on which they lie accounts for 50% of the Earth's surface, a sublime scale that is difficult to comprehend. If the oceans were to vanish overnight, we would discover that half of our planet is a vast desert of loose sediment. In the midst of this desolate landscape, the nodules provide a rare firm surface for life to cling to. Some sponges and mollusks are only found in their crevices, while nematode worms and crustacean larvae have also been discovered. The nodules are like rocky areas in a garden, where you're going to have more species living than if you had only soil. However, these nodules have recently caught the attention of a rapacious land mammal that requires them for its smartphones. What the expedition chemist missed in 1873 was that the nodules also contain metals like cobalt, nickel, copper, titanium, and rare earth elements. The oceanic nodules, which were once considered worthless, have now become increasingly valuable to humans as the demand for 21st century technology rises. Cobalt, for instance, is used in lithium-ion batteries that power cars and electronics. However, much of the world's cobalt supply comes from questionable sources, with over 60% extracted from land-based mines in the Democratic Republic of Congo that have been linked to human rights violations and child labor. Despite the engineering challenges of accessing them, oceanic nodules are becoming an increasingly attractive target. In one Pacific region, the Clarion-Clipperton Zone, CZZ, a conservative estimate suggests that there are about 20 billion tons of nodules that could be exploited. Though they were previously considered uneconomical to exploit for decades, several mining companies are now mobilizing to remove them, as well as other types of subsea mineral deposits. However, if the nodules are removed, what effect will this have on the environment? Researchers and mining companies began assessing both feasibility and environmental consequences in the 1970s and 80s by dragging specialized metal rakes and plows over the Pacific floor at various locations within the CZZ. They also conducted a discal or disturbance and recolonization experiment near Peru to scoop up the nodules and pull them to the surface. Although the experiment did not exactly replicate the dredging machinery planned for future mines and the scale was much smaller, the results are some of the best evidence we have. Therefore, though the oceanic nodules are a potential source of valuable materials, their removal would have a significant impact on the environment. The mining industry must weigh the potential economic benefits against the long-term environmental consequences and ensure that they are exploiting these resources in a sustainable and responsible way. Scientists have been curious about the long-term effects of deep-sea mining and its impact on untouched ecosystems. Mining companies have conducted test extractions to study their extraction technologies, and even the CIA, Ocean and Minerals Company (OMCO), and an industry consortium led by what is now Lockheed Martin conducted test extractions on the Hughes Glomar Explorer. These efforts have caused artificial trenches that have had long-lasting effects on the deep-sea ecosystem. Researchers have returned to these specific locations to study the long-term effects and have found that life in these artificial trenches has not returned to normal even after decades. The creatures that relied on the nodules which have now been removed are unable to recolonize, and others which require soft sediment to burrow and find mobile food are unable to survive on an artificially compacted surface. These communities of nodule-bearing abyssal plains will be especially vulnerable to the risk of extinction brought about by efforts to extract them. According to scientists, such effects could last hundreds if not thousands of years. Sociologist Barbara Adam proposed that the world can be thought of in terms of adjacent timescapes that differ in their pace. She described how industrial or agricultural timescapes move much faster than natural and ecological timescapes. All of these temporal regimes are intertwined, but when one is forced to move at the pace of another, long-term environmental damage occurs. The deep ocean timescape is slow and patient, but when humanity sends machines down to remove subsea materials, different time regimes collide. The pace of an oceanic abyss versus a fast short-term desire for new technology is a challenging problem. The deep ocean is a world apart from the lush ecosystems and bustling societies that thrive on land. The abyssal zone is characterized by freezing temperatures, intense pressure, and almost complete darkness. The organisms that live in this harsh environment rely on marine snow, a continuous rain of organic detritus that falls from above and is often digested 3 or 4 times over. This creates a low temperature, low food, and low energy environment that dictates the pace of life. Unlike the shallower waters, where physical changes can be extreme, disturbances in the deep ocean are likely to have long-lasting effects. Though these areas may seem like deserts, especially when compared to the vibrant corals found in shallow tropical waters, they are important reservoirs of biodiversity and play a crucial role in the carbon cycle through natural sequestration. Many of the animals found in the deep ocean are still unknown to science, and some contain pharmaceutically active compounds. In some cases, there are also long-term interactions with fisheries higher up the water column. The functions performed by these communities may not be valuable for centuries. However, the vastness of this space makes it difficult to capture its life in a photograph because the organisms are too small and dispersed. While there are no charismatic megafauna in the deep ocean, the abundance of life covering half of our planet cannot be ignored. Some may argue that destroying deep-sea life is a necessary sacrifice, especially when weighed against human rights violations in other parts of the world. Yet, it is unlikely that seabed mining will simply displace other forms of mining. There are various companies involved, different markets to some extent, and different demand-side pressures and incentives. Thus, if seabed mining does take off, it will likely become an additional source of minerals. The importance of deep-sea life is difficult to quantify in terms of human morality or economics. Nonetheless, it has intrinsic value. It is concerning that the slow and long-term timescales of this environment are easily disrupted. If future generations discover dredge tracks on the ocean floor, they will have outlasted the lifespan of the technologies that created them. According to David Ferrier, author of the book Footprint, these tracks become future fossils over time. Ferrier argues that in the Anthropocene, we are leaving behind unwanted industrial, chemical, and geological heirlooms that will last for centuries. Future fossils are our legacy and our opportunity to choose how we will be remembered. They will note whether we continued carelessly despite the dangers we knew lay ahead or whether we cared enough to change our course.